We have photographed a black hole, an object so extreme, so gravitationally violent, so remote from ordinary human experience that its existence was considered theoretical for most of the 20th century. We pointed our telescopes at a galaxy 55 million light-years away and captured an image of the shadow of a singularity at its center. 55 million light-years. A distance so vast that the light in that photograph left its source before multicellular life existed on Earth. We have detected gravitational waves, ripples in the fabric of space-time produced by two neutron stars colliding a billion light-years from here. Waves so faint that by the time they reached our detectors, they were stretching and compressing the distance between atoms by an amount smaller than 1,000th the width of a proton. And we felt them. We built instruments sensitive enough to feel the universe shiver from a billion light-years away. We have sent probes to the edge of the solar system. Voyager 1, launched in 1977, is currently more than 23 billion kilometers from the Sun, moving through interstellar space, sending back data from beyond the boundary of the Sun's magnetic influence. We know what the edge of the solar system feels like from the inside, because we put something there. We can do all of this. We have done all of this. And yet, we do not know what is orbiting our own star. Right now, somewhere in the darkness beyond Neptune, beyond the known edge of the solar system's planetary architecture, something may be moving. Something large. Something with enough mass to reach across billions of kilometers of space and leave its fingerprint on the orbits of distant worlds. Something that our models suggest should be there, that the mathematics of orbital mechanics insists is there, that the clustering of dozens of distant objects points toward, with a consistency that has convinced some of the most careful astronomers working today. Something we have never seen, never photographed, never detected directly in any way in our own solar system. In the neighborhood we have been studying for 400 years. If that is true, and the evidence is serious enough that it cannot be dismissed, then the most unsettling question is not whether Planet 9 exists. It is what its existence tells us about the reliability of everything else we think we know, about how complete our inventory of local reality actually is, about how much we are missing, not at cosmic distances, but right here, in the space between our sun and the nearest star. That is the question this video is going to follow. Let's start with the evidence. Because the case for Planet 9 does not begin with a theory. It begins with an observation that nobody expected and nobody could easily explain. In the outer solar system, beyond the orbit of Neptune, there exists a vast region of space populated by small icy bodies, remnants of the solar system's formation, objects that never coalesced into a planet, left over from the chaotic early period when the giant planets were migrating and gravitational interactions were flinging material across enormous distances. This region is called the Kuiper belt, and it extends from roughly 30 to 50 astronomical units from the Sun. 1 astronomical unit is the distance from Earth to the Sun, approximately 150 million kilometers. Beyond the Kuiper belt, in the even more distant outer solar system, there's a population of objects called extreme trans-Neptunian objects, ETNOs. These are bodies whose orbits carry them to extraordinary distances from the Sun, hundreds of astronomical units at their furthest point, before swinging back inward on highly elongated paths. They spend most of their orbital lives in the cold darkness of the outer solar system, moving so slowly at their most distant points that they barely seem to move at all against the background stars. In 2016, astronomers Konstantin Batygin and Mike Brown at the California Institute of Technology published a paper that changed the conversation about the outer solar system. They had been studying a group of 6 extreme trans-Neptunian objects and noticed something that should not have been there. The orbits of these 6 objects were clustered, not randomly distributed around the solar system the way you would expect from objects that had been scattered and perturbed by billions of years of gravitational interactions. clustered, aligned, oriented in the same general direction in space, and tilted relative to the plane of the solar system in a similar way. The probability of this clustering occurring by chance, given the number of objects and the geometry of the solar system, was calculated at approximately 1 in 150. Not impossible, but suspicious in the way that a coin landing heads 10 times in a row is suspicious. Not proof of anything by itself, but suggestive enough to demand an explanation. Battigan and Brown proposed one, a large, distant planet, Planet 9, whose gravitational influence was shepherding these distant objects into their clustered configuration, keeping them aligned, maintaining their orientation over billions of years through a gravitational interaction called orbital resonance, the same mechanism by which Neptune influences the Kuiper belt objects, the same mechanism by which Jupiter has cleared its orbital neighborhood of debris. If Planet 9 exists, the mathematics constrains what it has to be. It must have a mass of approximately 5 to 10 times the mass of Earth. It must orbit the Sun at a distance of somewhere between 400 and 800 astronomical units at its closest approach, on a highly elongated orbit that carries it to perhaps 1,000 astronomical units, or more at its furthest. It must be inclined to the plane of the solar system by roughly 15 to 25 degrees, and it must have an orbital period, the time it takes to complete one circuit around the Sun, of somewhere between 10,000 and 20,000 years. To put that orbital period in perspective, the last time Planet 9, if it exists, was in the position it currently occupies in the sky relative to Earth, humans had not yet invented writing. Agriculture was only a few thousand years old. The oldest cities were still centuries in the future. The entire recorded history of human civilization has elapsed during less than 1% of one orbit of this object around our star. Since Battigan and Brown's original paper, the evidence has grown. More extreme trans-Neptunian objects have been discovered and their orbital properties examined. The clustering has persisted. The statistical significance of the anomaly has grown rather than diminished as the sample size increased. Additional lines of evidence have emerged. The existence of objects with orbits nearly perpendicular to the plane of the solar system, the apparent alignment of the solar system's own tilt relative to the Sun's rotation axis, and other dynamical signatures that some astronomers argue are most naturally explained by the presence of a large unseen planet. The case is not proven. This is the honest position, and it matters enormously for understanding what the Planet 9 hypothesis actually is. A significant number of astronomers have argued that the orbital clustering is not as statistically significant as Battigan and Brown's original analysis suggested. That observational bias, the fact that certain regions of sky are searched more thoroughly than others, creating a non-random distribution in the known ETNO population that could mimic the signature of a real planet, may account for some or all of the apparent clustering. That when you correct for this bias carefully, the evidence for Planet 9 becomes weaker. This debate is ongoing. It has not been resolved. And the honest answer to the question of whether Planet 9 exists is that we do not know. The evidence is suggestive and has convinced a number of careful astronomers. It has not convinced all of them, and the only thing that will definitively settle the question is either finding the planet directly or demonstrating conclusively that the orbital anomalies have another explanation, which raises the question that sits at the center of this video. If Planet 9 exists, if something 5 to 10 times the mass of Earth is orbiting our star, why haven't we found it? The answer to that question is both technically straightforward and quietly disturbing. Planet 9, if it exists, is extraordinarily far away. At 400 to 800 astronomical units from the Sun, it receives between 160,000 and 640,000 times less sunlight than Earth does. It has no internal heat source to make it glow on its own. It reflects only a tiny fraction of the already minuscule amount of sunlight that reaches it. The result is that Planet 9 would be extraordinarily faint, orders of magnitude fainter than the distant objects we have, already detected in the outer solar system, visible only to the most powerful telescopes under the best observing conditions, and only if you happen to be looking in exactly the right part of the sky. And the sky is large. The region of sky where Planet 9 might currently be located, based on the orbital dynamics that predict its existence, is enormous, covering a significant fraction of the entire celestial sphere. Searching it systematically, with the depth required to detect an object this faint takes years of telescope time on the most powerful instruments on Earth. That search is ongoing. Several major surveys are currently underway. The Vera Rubin Observatory, which began science operations recently, is expected to be transformative for this search. It will survey the entire accessible sky repeatedly to depths that have never been achieved before. Planet 9 may already be in existing telescope data, hiding in plain sight in an image that has not yet been analyzed carefully enough to notice it. Or it may be in a region of sky that has not yet been observed at sufficient depth. Or it may not exist at all. But here is where the story takes a turn that goes beyond astronomy. If Planet 9 exists, it almost certainly did not form where it currently is. The outer solar system, at 400 to 800 astronomical units from the Sun, is extraordinarily sparse. There is not enough material at those distances to build a planet in any reasonable timescale, through the standard processes of planetary formation. Something that large cannot have assembled itself in the outer darkness, which means it got there somehow. And the two most likely explanations for how it got there are both remarkable in different ways. The first possibility is ejection. In the early solar system, the giant planets, Jupiter, Saturn, Uranus, and Neptune, were migrating, moving outward from their original formation locations through interactions with the disk of gas and dust surrounding the young sun, and through gravitational scattering of the countless smaller bodies that populated the early solar system. During this chaotic period, close gravitational encounters between the giant planets and other large bodies would have been common. A planet forming in the inner solar system could have been gravitationally scattered outward, thrown to the distant outer solar system on a highly elongated orbit by a close encounter with Jupiter or Saturn. In this scenario, Planet 9 is a world that formed near the other planets and was violently expelled to the outer darkness billions of years ago. The second possibility is capture. The Sun did not form alone. It formed in a stellar nursery, a dense cluster of hundreds or thousands of young stars, all forming from the same giant molecular cloud in close proximity to each other. During this early period, stellar encounters, close approaches between neighboring young stars, were common, and during these encounters, planets could be exchanged. A planet orbiting a neighboring star could have been gravitationally captured by the Sun during a close approach, settling into a distant orbit around our star, rather than the one it originally formed around. If this second scenario is correct, if Planet 9 is a captured rogue world, then it has a completely different history from every other planet in the solar system. It formed in a different stellar system. It spent its early life orbiting a different star. It experienced conditions, whatever they were, around that unknown parent star for some period of time, before being torn away and pulled into orbit around the Sun billions of years ago. A world with a foreign origin. A planet that does not belong here in the most literal possible sense. Orbiting our star not because it formed in our solar system, but because gravity and geometry conspired to pull it into our neighborhood billions of years ago, and it has been here ever since. Invisible, unreachable, moving through the outer darkness on its 10,000 to 20,000 year orbit, while everything else in the solar system, including the entire span of human civilization, transpired in the warmth of the inner system without any knowledge of its existence. And this is where the question that drives this video arrives in its full weight. We are an extraordinarily capable civilization. We have developed tools of detection and measurement that would have seemed supernatural to any previous generation of humans. We can detect gravitational waves from neutron star mergers a billion light years away. We can image the shadow of a black hole 55 million light years distant. We can track the orbits of tens of thousands of objects in the solar system simultaneously. We have sent probes to the edge of interstellar space, and we are still receiving their transmissions. And in our own solar system, in the space between our star and the nearest other star, there may be a world 5 to 10 times the mass of Earth that we have not found, that we cannot find with current technology without years of dedicated searching, that may be sitting in existing data waiting to be noticed. That has been orbiting our star for billions of years in complete anonymity while we developed civilization, science, philosophy, and spaceflight without any awareness of its existence. If something this large can hide this close for this long, what does that tell us about the completeness of our knowledge of local reality? Not cosmic reality, local reality, the space we live in, the solar system we call home. The honest answer is that our inventory is incomplete, not in the way that all scientific knowledge is incomplete, always growing, always refining, always discovering new details about known things. Incomplete in a more fundamental sense. There may be significant objects, worlds, in our own solar system that we do not know exist, that we have not detected, that our current surveys have simply missed because the sky is large, the objects are faint, and the search is hard. Planet 9, if it exists, would not be the first time a planet was predicted mathematically before it was observed directly. Neptune was predicted in 1845 by two mathematicians working independently. Urbain Le Verrier in France and John Couch Adams in England, based on perturbations in the orbit of Uranus. Within months of Le Verrier's prediction being communicated to an observatory with the right equipment, Neptune was found within 1 degree of the predicted position. The mathematics had seen it before the telescope did. The history of Neptune is either comforting or unsettling, depending on how you interpret it. Comforting because it demonstrates that mathematical prediction works, that the invisible can be found if you know where to look. Unsettling because it means there was a period, brief in historical terms, but real, when a planet the size of Neptune was part of our solar system, but not part of our knowledge of our solar system. When the inventory was wrong, when the map did not match the territory. We may be in that period again, right now, with Planet 9. And if we are, if the mathematics is correct, and the planet is real, and the search eventually succeeds, it will not just be an astronomical discovery. It will be a reminder that the space closest to us is not fully known, that the neighborhood we have inhabited for the entirety of our existence as a species still contains things we have not found, that the boundary between the known and the unknown is not located at the edge of the observable universe, or beyond the Planck scale, or in the quantum realm of subatomic particles. It may be located somewhere between the orbit of Neptune and the nearest star, in the dark, where we have not yet looked carefully enough. If you are drawn to the mysteries that exist not at the edge of the cosmos, but at the edge of our own knowledge of the familiar, if the idea that something significant might be hiding in the neighborhood unsettles you in exactly the right way, then Cosmora is where those questions live. Subscribe and stay. The catalog goes deeper from here. But before we close, here is the thought that belongs to you now. Look up on a clear night. Find the darkest part of the sky you can see. Somewhere in that darkness, in a direction you cannot determine, and at a distance you cannot feel, something may be moving. Something large enough to be a world. Something that has been moving through that darkness for billions of years, on an orbit so vast that the entire history of human civilization occupies a fraction of its journey around our star. It has never been photographed. It has never been named with certainty. It may not exist, but the mathematics says it does. And the mathematics has been right about invisible worlds before. we built civilization in the warmth of the inner solar system without knowing it was there. We developed science, explored the cosmos, mapped galaxies billions of light years away, and detected the whisper of gravitational waves from the far side of the observable universe. All while something the size of a planet may have been orbiting our star in the outer darkness without us knowing. That is not a failure of science. Science is finding it. Slowly, carefully, honestly. But it is a reminder about knowledge, about inventory, about the difference between what we know and what is there, about how the most significant things are sometimes not the ones at the edge of everything. Sometimes they are the ones closest to home, waiting in the dark, for us to finally look in the right direction